Hello, ladies and gentlemen. Welcome back to another lesson. Today, we're going to be talking about comparing real numbers. These are the problems that we're going to look at today, are ones they love to ask on the PSA and Keystone. Basically, they want you to figure out, how do you know which numbers are greater than or less than other numbers? How can you compare them to kind of figure out what order they go in from least to greatest, all right? So the first thing we're going to look at here is this question right here. We're going to put these in order from least to greatest. We have 2/3, 1/6, and -1/2, and they want us to put them in order, all right? So there's a couple suggestions I have for you to make these kind of problems easier on yourself, right? The first one is that when you go to compare these numbers, it is a lot easier to compare them if they are all in the same format, if you were. What I mean by that is that they should all either be decimals or fractions with the same denominator or common base, or integers if they can be, or whatever, all right? Now, when I look at these, a lot of times you're going to default right to, okay, let's just make them all decimals. That's easier, especially if they allow you to use your calculator. That becomes a lot easier, all right? But these ones all can have an easy common denominator that I can make them, which should make them a lot nicer to compare, all right? So I'm actually going to turn these all into out of 6. That's a common denominator for them. So this first one is going to become 4/6. The middle one's going to stay 1/6, and then the last one is going to become -3/6. And if you ask yourself, Mr. Guy, how did you get them to turn all into those numbers? I took this first one, I multiplied it by 2/2. That is what we call a giant 1. 2 divided by 2 equals 1, so I'm not changing my number, but 2 times 3 is going to give me that base of 6 that I want, and then 2 times 2 is 4. Same thing over here, but for this one I picked 3/3. Again, a giant 1, but 2 times 3 is going to give me that 6 number that I'm looking for, and so I end up with -3/6. All right, awesome. Now I got to go ahead and put these in order. Well, the first kind of trick I have is that anything that's negative obviously is going to be in the least side, okay? And then I can compare those numbers. So -3/6, that's going to be my smallest number I have. And then I kind of compare them by the numerator. Well, 1/6, that's definitely going to be the next number, and then 4/6. Now, to be careful, because is this really my final answer? Well, are those the numbers they started me with? Kind of, but they're transformed a little bit. I want to make sure I turn them back into the numbers they started as. So my answer that I really would want to submit is -1/2 followed by 1/6 followed by 2/3. And again, the big key is to make sure that you put them into the same format, either all common denominators or turn them all into decimals or rounded decimal approximations so you can easily compare them, okay? We're especially going to see that here. This actually is, right here, a Keystone problem from a couple years ago. And as you can see, they give us 3 numbers that are all in very different formats. We have a decimal, we have a fraction, a mixed number fraction, we have an improper fraction, and we have a radical. We have a square root here, okay? So again, the first thing I want to do is turn these into things I can easily compare them as. And because I have this repeating decimal, because I have a radical here, I'm going to turn them all into approximations. I'm going to turn them all into decimal approximations. This one's already that. I can leave it, okay? This one, 3/4 is 0.75, so I'll rewrite this as 4.75. And yes, before I start trying to order them, I got to go through these steps here, so it's a lot easier for me to do that. Okay, let's skip square root of 20 for right now. We'll come back to that in a second. 17/4, well, let's see. 17/4 would be 4, 8, 12, 16, so that's 4, and then 1/4 left over. So that'll end up being 4.25. Okay, so I have these so far, 4.74 repeating, 4.75, 4.25. I need to figure out the square root of 20. So the easiest way to approximate this and kind of turn into a decimal approximation, if you have a calculator, obviously put in the calculator to get the answer. But if they tell you on the PSSA, for example, this could be in a non-calculator section, you would have to do it by thinking of your perfect squares. Well, what are your perfect squares? Let's see, the perfect squares are the numbers that when you multiply them, a number by itself, you end up with a perfect square. So like 1 times 1 is 1, 1's a perfect square. 2 times 2 is 4, that's a perfect square. And what's nice about the perfect squares is that the square root of them is a number that we know. So for example, the square root of 4 is equal to 2. Hey, I knew that because I know that 2 times 2 is 4. So let's kind of think of our perfect squares to figure out where this number square root of 20 is going to be. So 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25. So therefore, we know that this falls in between 16, the square root of 16, and the square root of 25. And in fact, I can think about the fact that it's about exactly in between. So the square root of 16 is 4, and the square root of 25 is 5. So I know that this number is pretty much directly in between 4 and 5, okay? It's a little bit closer to 16 than it is to 25, so it's a little bit less than 4.5, okay? So I know it's going to be somewhere, this square root of 20 is going to be somewhere a little bit less than 4.5. Now, I'm just going to write 4.5 up here, and you might say, well, Mr. Guy, is that really exactly what the square root of 20 equals? No, it's not, okay? If you have a calculator and you're allowed to use it, you could put it in and get well, it's going to be rounded, but the rounded decimal is exactly what it is. But this number right here, the 4.5, is good enough for me to go ahead and put these in order because I know that it's going to be greater than the 17/4, but it's going to be less than the 4.74 repeating. So I know that the square root of 20 is going to be 1 up from 17/4. So let's see, we have 17/4, square root of 20, and then 4.74 would be the next highest, and then 4.75 would come after that. Okay, again, when I look at that, I see 4, I see 7, and then the next number, even though it's 4 going on forever, 5 is greater than 4, so this one is going to be greater than that. So actually, A is going to be our answer. Okay, so just looking at these numbers we have lined up here, okay, we have 4.74 repeating, 4.75, okay, 4.75 is greater than that, 4.5 is less than that, and 4.25 is less than that one. So this one's right in order of how I want it, all right? So that's kind of our main goal for today is just getting these numbers and putting them in order. We want to make sure we, A, turn them into all the same format, whether that be decimals or fractions with the same denominator. And then once we have them in the same format, it's pretty easy to see, okay, what's greater than, what's less than each other. Thank you all for watching.